This time we are going to create a Swing application that connects to a SQLite database file. Our Swing app will execute some SQL commands such as first, select, to extract some student records satisfying some conditions. Second is insert, to add a new student record into the SQLite database. Third is delete, to delete existing student records from the SQLite database satisfying some conditions. And lastly, update, to edit some data fields of existing student record or records satisfying some conditions. But first, let's discuss shortly some background information about RDBMS, JDBC, and SQLite. Now, what is RDBMS? It is simply a relational database management system. It is a database management system based on the relational model of data. Most databases in widespread use today are based on this model. RDBMS has been a common option for the storage of information in databases used for financial records, manufacturing and logistic information, personal data, and even student information system, and many other applications since around 1980s. Relational databases have often replaced legacy hierarchical databases and network databases because they are easier to implement and administer. The idea is that just like in a student information system, we represent the student records as a table like the one shown here, where each row represents one student record. Okay, so this row here, the first row is student record number 1, the second row is student record number 2, and so on. Now, all of those student records have common data fields. Okay, and like for example, all students have IDs or name, course, year, gender, score, total points of the exam, grade, remark, and for clearance. Okay, cleared is true if have submitted already. The clearance, false otherwise. So the rows are the student records and the columns are the data fields. Now, we usually have a primary key. What is that primary key? It is the column or the data field wherein all values are unique for all student records, meaning there are no duplicates. Like in the case of students, there are no 2 or more students with the same student ID. Okay, each student has a unique ID. Okay, so in the database table, we assign this column or data field as a primary key to mean that there must be no duplicates. Each ID is unique to each student. What is JDBC? That stands for Java Database Connectivity. This is simply an application programming interface or API for the programming language Java, which defines how a client may access a database. It is a Java-based data access technology used for Java database connectivity. It is part of the Java Standard Edition platform from Oracle Corporation. It provides methods to query and update data in a database and is oriented towards relational databases. SQL is a structured query language. It is a domain-specific language used in programming and designed for managing data held in a relational database management system or RDBMS. Now, Being a language, it has some instructions or commands. Okay, this one here is the syntax on extracting some records from the database table, and you could specify what columns you want to extract, or you could replace it with asterisk if you want all the data fields or all the columns to be extracted. Okay, but if you want only 1, 2, or 3, then you specify it here, separated by a comma. And only those records satisfying this condition will be extracted. So we use the keyword to extract as select, and for the condition, the keyword where. We have here some examples. First, to select all column fields like ID, name, course, year of student records whose year level is 3, then you issue this SQL command. Select ID, name, course, year from, this is the name of the database table where the year level is 3. So all the student records whose year level is 3, all of them, okay, all those 4 columns of all the student records will be extracted. For example number 2, this is to select all columns of all student records whose course is BS-CPE. So asterisk mean all columns. All columns of those student records with a course BS-CPE. So only BS-CPE student records are extracted. For example number 3, this is to select all columns, okay, because that is asterisk, all columns of all student records whose course is CPE and the year level is 3. So take note of the end, which means that these 2 conditions must be true. Okay, so the command is select asterisk from student. Okay, again, this is the database table where the course is BS-CPE and year is 3. So all the third year CPE students are extracted. In example number 4, we use the logical operator OR. Okay, this is to select only these columns, ID, name, course, year. So only 4 columns, ID, name, course, and year, from this database where the year level is 4 or 4th year, or the remark of the exam grade is excellent. Okay, so all 4th year and all having a remark excellent will be extracted. Not 4th year with excellent remark, but all 4th year regardless of the remark, and all year level for records with excellent remark. So this is union. Take note, OR is union, while AND is intersection. The 5th example is to add. Okay, so we use the command insert to add a new student record into the student database with column fields ID, name, course, year, and the values of this data fields would be this one for ID, this one for the name, this one for the course, and 4 for the year. Okay, all the rest of the columns are not assigned values. So as a result, the student database file will have 1 additional student record because we added a new student record having these details. In example number 6 is to delete the student record whose ID is this one. So it is assumed that there is a student record that exists in the database table having this ID, or else an error would occur. So what is the SQL command for that? It is delete from the database, which is student, where this specifies the condition. What student record are you going to delete? It is the one whose ID is 2018-016. And the last example is how to edit or update an existing student record. So say you want to edit the score, grade, and remark values, only these three data fields of an existing student record with this ID. Okay? So we say update student. This is again the database, and set the score to 99, grade to 99, remark to this value where the ID is this one. So what will happen is that this will be searched, the student record with that ID, and then the values of score will be changed to that value, the value of grade will be changed to that value, and the value of remark will be changed to that value. Okay, so that is how to edit an existing record or row. Now, just a little background about SQLite. It is a relational database management system contained in a C library. It is file-based database. It is self-contained. It is serverless or not a client-server database engine. It is a smaller database compared to server-based databases such as PostgreSQL and MySQL. Okay, so these two common database engines are server-based. Now, most mobile apps and computer apps use SQLite rather than the server-based databases because the server-based databases is tedious to manage, it's tedious to maintain, and even to configure, while SQLite is easily configured. Now let's go to our Eclipse IDE. I already have here a working, functional, running program application. I named it Student Database. So in case you have not created a project yet, you know what to do, and that is to click this one and select Java project. Okay? And afterwards, say for example, you have already created the Java project, new DB SQLite, then you select that one and click this one and go to Swing and select Application Window. And then give it a name, Student Database. Okay? So remember, the naming convention for Java class is a Pascal convention, that is, first letter of every word is in uppercase. This is our GUI for the app. Now you know already how to add all of these components. These are labels, these are text fields, these are buttons, and these are buttons, and all of these are buttons. And this is a JTable surrounded by a scroll pane. And when we go to the source tab, all of this except for some methods are automatically generated when we add all of those components on our frame or our window. So once those components are in place, we need to declare this one. You know this already from our previous Swing app. Okay, you need to declare a model which is type default table model, and we put this one here on top as a global, like a global variable, so that it could be accessed by other methods, not just by one method. So we make it global. Now aside from that, we need to declare this objects. Con is type connection, okay? And we initialize that to null. And this one is type statement. And this one is type prepared statement. And this one is result set, okay? So let me explain to you the execution. So when we run the app, okay, this is executed, the initialize. Okay, so all of the components, the frame is created and all the components, all of this, okay, up to the last. But of course, the events are not executed unless we do the mouse click or the mouse down actions. So after the initialize, where is that? Okay, so after the initialize, we call the method dbconnect. Okay, so this is our first step. Get a connection to SQLite database. Okay, so this is a user-defined method and it returns a connection type, assigning that to our object con, which we define on top here. Okay, so for the dbconnect method, okay, which returns type connection, what we do here is first we load Java's JDBC SQLite driver. Okay, and this is the statement how to load Java's JDBC SQLite driver. And the second step is get a database connection. Okay, and then assign that to con. Now, we call this method getConnection, passing as parameter this one, this string, which specifies the location of our SQLite file, database file. Okay, so it's in D, drive D CPE 121 Java. Let me check on that. Drive D CPE 121 Java. Okay, that's our SQLite file. Okay, later I will discuss with you how we create this one. Okay, so JDBC colon SQLite colon and then the directory. Okay, the SQLite, the student.SQLite that I have shown to you a while ago, this one was created using this SQLite manager, but actually you could use any other available SQLite manager or editor or app. So let me show that this one is the SQLite manager. Okay, it's unregistered, but anyway, it would allow you to create SQLite database file. After that, this method is of course under the driver manager type, which of course that is included in our JDBC. And next is we prompt the user if connection attempt is successful by showing a message dialog, okay, using the J option dialog box, connection successful. If there is an exception that occurs here, and most of the time the exception that occurs is in connection with connecting to the SQLite database error. So we prompt the user that the attempt to connect is unsuccessful due to some error, which is we display it here, okay, because the error type would be stored here and we display it here, okay, the details of the error. Once that is successful, okay, so we are done with this. We have established a connection. And then, going back to our GUI, the first thing we want to happen is that when we click this button, it will load the database or the student records stored in the SQLite database file to our JTable. Okay, so let's double click that one to see the event. Okay, so when you double click, remember the method is action performed. And how do we load the database to our table? The first, after you have established, step 1 is establishing a connection, the DB connect a while ago. Step 2 is to prepare the SQL command. Okay, remember those SQL commands that we have discussed earlier. So we put into a string type named query our SQL commands. So since we want to load all records to the table, so we say select all asterisk from student, because our SQLite file is, what is that again? It is a student. That's the name of our SQLite database file, student. Okay, so select all data fields from student, and there is no condition, so all the records will be extracted. So we put that SQL command in string variable query, and we pass that SQL command to our method prepare statement. Okay, so we use the prepare statement to assign the SQL command in the connection, in the earlier established connection, and we named it PST. And then the prepare statement is then executed. Okay, and it returns a result set, which is RS. Okay, remember RS is result set type. And afterwards, this result set, the one that contains all of those records that we have extracted from the SQLite table, we pass that to this method, result set to table model. And what this method does is it will display on our JTable all the records in the result set RS. Okay. Now remember how we add rows to the JTable in our previous lesson. We create while RS next is true, meaning while there is still a student record in the result set, we're going to form or create a row, which is a one-dimensional array of object of all of these data fields. So one student record, all the data fields in here from ID up to cleared, that's one row. And then we add that row to our JTable model. And then we increment count so that we can keep track of how many student records were already added in our JTable, wherein we initialize count to 0. And by the way, before all of this, we need to reset or clear the table model. Okay, so clear the JTable first before we add the new selection or the newly extracted records from the SQLite table into the result set. So again, the student records coming from the SQLite database file will be set to the result set RS, and then the result set RS, we extract each one and add them as one row to our JTable model. And then after, when all of the rows or student records were already added, we display the total students, which of course is equal to count. Okay. Now, if there is any error here or exception, runtime error, then this would be displayed. Okay, there is something error in the result set or accessing it. Now, this is called every time you execute an SQL command. So that is executed when we load all records to the table, and say this one, which is the course button. This is the course button. Okay. When we type in here, say BSCPE, and then click this button, it will extract all of the student records having that course and display them all in the JTable. If we click this button, then what happened is that all the student records whose year level is specified here will be extracted and it will be displayed on the JTable. The same would be true for gender button. So you specify here what gender, female or male, and then when you click this one, all of those say male in the student in the SQLite database will be displayed here. All male will be displayed, or when it's female, all female will be displayed. And for remark, that's also what will happen when you type in, say, average here and then click this button. All student records whose remark is average will be displayed here. And say we type in here false and click this button, then all the student records with a false data field for cleared, or those that did not submit yet their clearance, will be displayed here. Okay. When you click this one, okay, say let's double click that. What will happen is we're going to add a new student record. So remember the insert SQL command. Insert into our SQLite database a new record, okay, for all these data fields or columns, and this would be the respective values of those columns in that new student record. Okay. So we create, the first thing we do when we add is first, via that established connection, we create a statement, and then we execute the update, which is this one. We execute this is how you execute the SQL command, okay, by calling on the method execute update new statement. Okay. And by the way, what did we add? Okay, 2016, okay, something like this. For the delete, double click that. So again, what we did is we create a statement, we prepare the statement, and then we assign what statement or SQL command to be executed, and this method would execute that. And this time it is to delete from student, where ID is this one, okay, which is we're going to delete the student record with the ID 2018-016, okay. We add it here, and then we delete it here, okay, just to demonstrate to you how to add and how to delete student record from or to SQL database file. And for the edit, this is for the update. The same is true. You create a statement in that established connection earlier, and then this is the SQL command, update student whose ID is this one. So the student record to be updated is the one for the one with the ID 2018-001. And what are we going to update? The data field score, we changed that to 99. The data field grade is changed to 99, and the remark is changed to excellent. Only for that student record whose ID is this one. Okay. And then we have here some other buttons, course and year. This would extract all the student records whose course and year are whatever is specified in these two text fields. Okay, so take note, it is and. So both these two conditions, course and year, must be true. For the year or remark, it will extract all the student records whose year level is equal to that, or the remark is equal to that. So or is union. All of those year level and all of those remark, whatever value are here. Okay. While this one, it is course and year. So intersection. And then the clear filters is simply to clear all the values that were entered in here. Okay. So when we double click that, we simply set text with the method set text to clear all of those written or entered in those text fields. For the course and year, let's look at that. So our SQL command is select all from student database where the course is equal to course. And what is course? The one that we get from the course text field, which is this one, the course text field. Okay. And then for the, where is that? The year, course and year. Okay. And the year is, so take note, course and year, where year is equal to the one that we have entered here. Okay. So once we have set the SQL command, we then pass it here and prepare the statement in the connection, and then it is executed here. And the records that were extracted are assigned here or stored here in the result set RS, and then we display that on the J table. Okay. So for the year or remark, it's the SQL command is select all from student where year is the one that we have in the text field and the remark is the one we have in the text field of remark. And then we prepare the statement, which is that statement or SQL command, and execute it here. And then the extracted records are assigned to RS, and then we display those records in RS into our J table. Okay, so how about for the exit is, you know this already. So let's take a look at this one. So the same procedure, you're going to prepare the SQL command, select all from student where the course is that. So we only extract for the course which is specified in the course field. So the same is true for this one. We extract the year from the year text field, and that is what we pass to the SQL command. So all records whose year level is equal to that which is specified in the text field, and then prepare the statement, execute the SQL, and then the result would be stored in the J table or copied into the J table. Okay. So they have the same procedure, all of those buttons here. Before we run our application, let me show you the SQLite database content. So let's open the SQL Manager. Click OK. And this is the file, drive DCPE 121 Java SQLite, student.sqlite. So, or you could double click this one. Okay, so that's the table name, student. And this is what's inside. I already populated this with student records. So let me just expand this so you can see all of them. Okay, so from ID 2018 1, 2, 3 up to 15. So we have 15 student records. Okay. Later I will show you how to create an SQLite database. So let's go back to our code. Say let's run this. Run as Java application. Okay, take note of that. Connection is successful. Click OK. And we have this. Okay, we load database to table. Okay, so compare it with what we have in here. Okay, so everything that's in here, that is what we can see here. Okay, and then let us close now this one. So say we want to add that new student record. Okay, let's go to the add. Where is that add event? We're going to add okay, so we're going to add 2018-016 Brian Will, all of those details. Okay, so it would be added below. So let's click add. After that, we load the database to table. And take note, we have already in here Brian Will. Okay, this one that we have added. And then say we're going to delete that. Okay, remember what we are going to delete? The ID 2018-016, which is the newly added student record. So let's delete that one. Okay, delete, and then refresh the J table. Okay, take note that we don't have any more the newly added Brian Will. Okay, it's already deleted. Say we want to edit. What are we going to edit? The first one, right? So in the edit, where is the edit? Here. We're going to edit the student record whose ID is 001. So we will make the score to be equal to this, the grade to that, and the remark to that. Okay, so currently, for 001, Juan Cruz, the score is 83, the total is 100, grade is 83, and the remark is fair. So this will become 99, 99, and this will become excellent after we edit. So let's click edit and then refresh the database. So notice that it's already 99, 99, and excellent. Okay, so we're done with the adding, delete, and edit. This time let's extract some records. We want to extract all the fourth year, we get